to college calculus. Today our topic for today is the tangent problem. The tangent problem, find the equation of the tangent line to the parabola that we have here. So the problem is y equals x to the second power at the point 1, 1. Okay. The tangent of the problem is we used to call when you have the circle like this, the tangent is a line that touch one point of the circle. Okay, that's called the tangent problem. But in this case, we have one problem to solve here. Okay, the solution to this problem, y equals to the x power at the point p1, 1. Okay, the solution will be able to find an equation of the tangent to this point, to this line T, the blue one. As soon as we know the slope, we need to find the slope. The problem here is we have one point. We need 2 points to find the slope. Okay, but observe that we can compute approximation to the or the slope by choosing the nearest point to this tangent. And you make another tangent here touching 2 points of the parabola. We can choose the nearest point to this one and then computing the slope slope PQ, okay, of the second PQ. This is the point point Q here, x to the x power, and then point 1, 1 right here. But we have two lines here, 2 seconds. One is t that we have to find the equation of these seconds. Okay, we have to find the equations. We choose in this case x different of 1. So this means that q is different to p. The MP here, the slope, m p q. This mean slope is equals, in this case you take this point, is going to be, you using the formula for find the slope, it's going to be x to the second power minus 1, the point over x minus 1. Okay, for instance, for the point, let's do a little table to help to find the near point, the slope or the seconds. If you make this little table, x, let's do x here, like this, slope PQ, PQ, like this, using some points. For instance, let's write here 2 here, and 3 here. All right, then you make it smaller, so 1.5 here, and then here it's going to be 2.5, and then 1.1 here, so 2.1 here, and then 1.01 is going to be 2.1, 01. Here 1.001 is 2.001. all right, so divide it here, and then maybe use different kind of numbers here. You do here, for instance, 0 here, you check this different different numbers on the table. 0 here, x0, and then 1 here, for instance. The next point, 0.5, here is going to be 1.5. You choose 0.9, this is 1.9 right here. You choose 0.9091, and 1.9090, 91. You choose 0.999. It's going to be here 1.999. Okay. Okay. I think it's enough. So you use this little table to help to find the other point here, the other point, and the other point. Okay, look at this. We are gonna have Q here. Q is going to be for instance, yeah, point Q. Write 1.5 here, comma 1.5 here. This one, 2.5 here, 2.5. It's another point. We have here. We have MP here. Now MPQ. I mean MM means slope. Okay, it's going to be equals. It's another way. 2.25 minus 1. So this is the point that we have it, and the second divided by 1. 1.5 here minus 1. This is going to be equals here 1.25, and then divided by 0.5, and then this is going to be equals how much? Going to be equals 2.5. See, it's equals 2.5. So it's I think the slope is close to almost finishes. It's closer to number 2, right? This suggests that the slope. This suggests that the slope of the tangent line should be m equals 2, right? Because we are talking about a near point. So the slope of the tangent line is limit of the slope over the secant lines, like this. So you write it right here, limit Q, when Q go to P, is M here, M, P, Q is equals M, right? And limit here, X, when X go to 1, so it's X2 minus 1, X divided by X minus 1 is equals 2, right? It's right there. See, so this means that the slope is equals to 1. We have the once we have the slope, when you know where is the slope here, then it's easy to find the equation of the tangent. Why is easy? So look at this. I'm going to erase this information here. See? And then write point slope form. Remember the formula? Point slope. Remember this form. When you know this of the equation of the line. Point slope form of the equation of the line. What is that formula? So the formula, so right now we know that the slope is equals to, so I'm going to erase this. So the slope is equals to, remember, don't forget, write the equation of the line. The equation is going to be, write it right here, y minus y1, okay, equals m times x comma x1. So this is the equation. This is the point slope form of the equation of the line. So now you substitute this. We are going to have, because right now we know that slope, let me write right here, m is equals to, here you're going to have y minus 1, see, the point, equals, how much is the slope? The formula, this is the slope is equals to times x comma 1, this case, see? And then you solve the problem, this, you simplify this, we are going to have, or we're going to have y, you substitute, simplify here, y is equals 2x minus 1, right? This is the formula, the equation or the tangent line to the parabola, this parabola that we have here in this graph. This is our solution to this problem, to this parabola. Okay, that means the solution of the t we are looking for, the equation of the tangent line to the parabola y equals x to the second power at the point P at this point. We are looking for, remember, the tangent t. Okay, thank you so much.